So here in example 2, we want to find a solution of y double prime minus 2y prime equals 0 that satisfies the condition y of 0 equal 1 and y prime of 0 equals 3. So this is just saying that you've got to go through the point 0, 1, because 0 is your x and 1 is your y. And then y prime of 0 is going to be slope of the tangent at 0. So this is saying slope of the tangent at 0 is 3. Well, let's see how we do this. We were given forms of solutions there, and what we're going to do is we're going to plug in t values to our y and y prime to get our constants. So recall that our one parameter family was c1 plus c2 e to the 2t, and then our y prime was 2c2 e to the 2t. So that was from example 1. So what we're going to do is we're going to take and plug a 0 into the y function, set it equal 1. So I plug 0 in here and here, so here and here. And then e to the 0, that's just 1. So this is just c1 plus c2 times 1, which is c1 plus c2. And then we got to set that equal 1. So that gives us one equation in c1 and c2. Then we also know y prime of 0 is 3. So that refers to this equation. So y prime of 0, we're going to plug 0 in here and here. So 0 here and here. And then again, this is e to the 0, which is 1. So that's just 2c2. And we set that equal 3. So then if we divide by 2 here on both sides, we get c2 is 3 halves. And then we can plug that back in the first equation to find c1. So c1 plus c2 will be c1 plus 3 halves, which equals 1. That's this equation. Plug it in c2. And subtract 3 halves on both sides, so bring this over as a negative. And 1 minus 3 halves is negative 1 half. So now we've got c1 and c2. That gives us a specific function out of this 2-parameter family. So that means that our solution now is negative 1 half plus 3 halves e to the 2t. So I plugged negative 1 half in here and 3 halves in here. And that gave us a specific function. Now if we look at the graph, this is an exponential function, and it is the specific function that goes through the point 0, 1. That's this condition. And if you graph that function and look at the slope of the tangent line, that's this condition. That slope should be 3. So that's what those initial conditions are doing for us. They're sorting out of that 2-parameter family of functions, which is the unique function that goes through this point and has this slope.